Hi everybody, it is your host with the most, Miss Stefan, and I am back for us to do another little collaborate session. Today's topics, and again, I'm writing with a stylus, so you know I can only write so neat. So today, oh my goodness, bear with me, it's being difficult. Today, what is this? All right. Hello everyone, and welcome to another super exciting session of Lab Math through Collaborate. This is your host, Ms. Stefan, and today I'm trying to keep the files shorter so that they're easier to bring up. We're going to talk about ratios, proportions, and temps. For some reason, my stylus is being difficult. So those are the topics that we're going to talk about. I might stop, depending on time, after ratios and proportions and do temps in a separate one so that everything works well. Okay, so I want to make sure that it's, let's try that. Okay, so to keep things relatively simple, ratios and proportions are like peanut butter and jelly, right? So ratios describe an amount. At least two values are involved. You have a certain amount of one thing and a certain amount of another thing, okay? And so you're going to shorten that up and describe it as a ratio. Whereas a proportion involves, it's a determining the quantity of the given ratio. So once you have the ratio, you can break that down to give a proportion. And so that's why they're like peanut butter and jelly. So let's kind of do a little example. Let's just make a new page. Okay, so let's take an example that we have 5 grams of something. It turns my pencil off. 5 grams, okay, of something, and we are going to put that into 100 milliliters of something else. You can make this whatever one you want it to be, right? So our ratio is pretty simple. What is it, guys? I'm going to give you a second. Okay, 5/100ths, right? So your ratio is 5/100ths. Now remember, you always want to break that down, right? So does 5 go into 100? Yes, it does. So 5 becomes 1, goes into 100 how many times? 20. So your final ratio is 1 to 20. So you have 1 part of your grams to 20 parts of your milliliters. That is the ratio of what we are making, okay? The proportion Greetings everyone, how we doing? So this is Ms. Stefan, and I am back to do another session about lab math to try to make it a little bit more understandable. So today we're going to talk about ratios and proportions. Which are like peanut butter and jelly. One of my favorite sandwich personally. Okay, so what are they? A ratio, to keep it very simple, is the amount of one thing relative to another thing. It's a comparison of two values, and it's breaking those values down into their smallest form. So just to keep it pretty simple, let's say we had 5 grams of something in 100 milliliters of something else. And you can make it exciting if you wanted 5 grams of chocolate and 100 milliliters of milk. You know, if you like chocolate milk, or 5 grams of chocolate in 100 milliliters of coffee. You go wild with it. So your ratio here would be 5 to 100, but can you break that down farther? The answer is yes. If you go back to your basic math, 5 does go into 100 20 times. So then your final ratio is 1 to 20, right? Or if you know, this is an example of a ratio. Now, let's talk a little bit about its friend proportions. Proportions are used to determine quantities from given ratios. It's two ratios that are equal. So we just described a ratio, but now we're going to describe ratios in the sense of proportions. So we're going to take two different ratios and kind of put them together to determine proportions, right? So let's look at an example here. I'm trying to pick a good one for you guys. All right. So if we have two ratios, right? Are these equal to give us an equal proportion? That's what we want to figure out. Does this ratio equal this ratio to give us a proportion? Well, does 1 to 2 equal the same thing as 3 to 6, right? So 1 is going into the number 2 times, right? So 1 is going into 2. Here we have 1 going into 2 again, because 3 goes into 6. How many times? 1 to 2. So these are equal proportions, and I just did a G instead of a Q. My bad. Okay. So let's do this. Let's do a proportion ratio problem so that we can kind of correlate the two things. All right. So let's say we need 5 grams of sodium chloride. I know it's not nearly as exciting. Sodium chloride into 1,000 mils of a solution. Now, this right here would be a ratio problem that we would do, okay? So the 5 would go into 1,000 and so on and so forth. What makes this a proportional problem is that we're going to need additional information. We only need 500 milliliters of solution. So we have 1,000. We only need 500. Okay? So the question is, how much sodium chloride is going to be needed for that? So if we were to keep this a simple ratio, so as a ratio, it would become 5 to 1,000, which we would break down further. How many times does 5 go into 1,000? Let's see, do you guys know this? Come on. You should know. Okay. Is that right? Think about it. That's not right, is it? Now, Hi everybody, this is Ms. Steffen, and today we are going to talk about another lab math topic of ratios. Let me hold the screen a little tighter, and proportions, which are like one of my favorite sandwiches, peanut butter and jelly. I prefer strawberry to grape, but to each their own. Okay, so what are a ratio and a proportion? A ratio describes the amount of one thing compared to the amount of another. So a ratio always involves two values. And usually, you're almost always going to be given both of those values, okay? They can be, you know, and we take them down to their simplest forms, right? So, for example, let's say that we have 5 grams of one thing, and we have, let's say, about 100 milliliters of something else. Now, you can make them what you will. One could be chocolate, one could be coffee, what have you. So, this would become a ratio of 5 into 100, or we could break that down further. How many times does 5 go into 100? So that would be 1. 5 goes into 120 times. So our final ratio would be 1 to 20. And that represents this relationship right here. So we would say that it's a 1 to 20 ratio of how much we have of the solid part versus the liquid part of this ratio, okay? And remember, you always want to break it down to its furthest point if you can. Now let's compare that to our friends' proportions, which are similar. Oh my gosh, this pen. I'm sorry guys, I'm trying to hold the screen as best as I can. Let's just redo that. Okay, so proportions are just a little bit different. They are used to really determine the quantity of given ratios. So usually a proportion is an equation that states 2 ratios are equal. And the reason for that, so we're going to have 2 ratios in a proportion, is because we can use proportions to help us solve problems where we have some of the information but not all of it, okay? So when you're asked to do a ratio, you're almost always going to be given all of the values you need, and you're really just breaking them down. When your questions are related to proportions, you are going to have to kind of solve for X almost, if you will. You're going to be given part of the information of 2 ratios and have to utilize them to figure out what the overall proportion is. So hopefully that makes sense to you. So let's try to do an example of a proportion problem, okay? Let's start off with making it a ratio. So let's say that we have 5 grams of sodium chloride. Actually, bear with me a second. I'm going to see if I can just flip my screen and work this way. And hopefully it will allow me to do that. And that way, I can put better pressure on this. Oh yeah, okay. So we have 5 grams of sodium chloride, right? And we have 1,000 milliliters of solution. Now if this was just a straight up ratio problem, we would be able to say 5 grams into 1,000 mils. Our ratio, 5 goes into 1,000 100 times. So our ratio would be 1 to 100. Because remember, always break it down to its lowest point. But that's not what this problem is asking. So there's our ratio from the information we were given. But then the problem states for us that we only need 500 mils of the solution. We don't need this whole 1,000. We only want 500 mils of it. So then we have to figure out how much sodium chloride we need. Okay, so again, we have 5 grams of sodium chloride. We have 1,000 mils of a solution. But for our purposes in the lab, we only need 500. Okay? Well, we can't just dump all of this sodium chloride into that because we want to maintain that 1:20 ratio. So if we're only using half of this solution that is not described, we can say it's distilled water for our purposes. We need to figure out how much we need of the sodium chloride. So we set that up as a solve for X problem, and that's how we determine proportions. So what we're going to do is we're going to take the facts that we know and plug in the ones we don't. So we know that we have 5 grams to 1,000 mils. Okay? What we need to figure out is how many grams for 500 mils. Okay? And you're going to cross multiply. So when you do that, when you cross multiply, it's going to be 5 grams times 500 milliliters over 1,000 milliliters, right? Okay. So 5 times 500 is what? So we have 2,500 grams per milliliters over 1,000 milliliters. Oh, sorry, I left a 0 off here, right? So 2,500 grams per milliliter, and we're going to take out our milliliters because they're factored in with both, divided by 1,000, and that's going to give us 2.5 grams of sodium chloride. And that is what we need. Now I realize that this problem, was basic division, but I wanted to go through the process because not all of our examples are going to be this easy. Okay, so hopefully you kind of get a feeling and you understand the way that they work. So let's go through a couple of the practice problems. Now please don't forget, these practice problems are available in the learning module. They are there, and then so are the answers after the fact. So what I'm going to do is I'm going to go through like 1 or 2 of the ratio problems and then 1 or 2 of the proportion problems, and then I want you to work on the rest. But hopefully this is helpful. So you have the homework problems. We're going to do ratio problem number 1. And ratio problem number 1 is to mix an ultrasonic cleaning solution. We need 10 milliliters. We have 10 milliliters of concentrated cleaner added to 500 milliliters of distilled H2O. Okay? What is the ratio of cleaner to water? Again, ratios are pretty simple. Make sure you read what the questions are asking, right? Okay, so 10 mLs into 500 mLs, right? So 10 into 500 is 1 into 50. So your ratio is 1 into 50. You can write it like this, or you can write it like this. Either way of writing your ratio, that is the correct way to write it. I'll accept both in your homework because both are representing the ratio. It's just a matter of preference. Let's do another one. So we're going to do, let's do number 3. Okay, so the label on a gallon of ice cream, and I happen to love ice cream, by the way, shows that the total fat content is 12 grams, of which 8 grams is saturated. Okay, so we have 12 grams of fat, 8 grams of it is saturated, right? What is the ratio of saturated fat to total fat? Pretty simple again. So we're going to take our 8 grams of saturated fat over our 12 grams of regular fat, and we're going to break that down. 8 into 12. Can we break it down farther? Yes, we can, because both of these are divisors of 4. So that will break down into 2/3, or 2 and a 3. So our ratio is 2 out of 3 is saturated fat. So the ratio of saturated fat to plain fat is 2:3. 2 and a 3. So either one of these is correct. Don't forget, in ratios, it's pretty simple math for the most part, but break it down to its furthest number. Sometimes the first ratio number you get, like right here, is as far as it can break down, and that's okay. That will happen. I just want to make sure that you guys remember that it's important that you always break it down to its lowest point, okay? So ratios is pretty simplistic, I think. They're not too complex. So let's talk about proportions, which are taking usually 2 ratios, as I mentioned, and figuring out a problem. Okay, so let's see. I'm looking at the proportion problems. Let's start with proportion problem number 1 from the practice homework. A patient is to receive 50 milligrams of Demerol. Okay. The tablets are 25 milligrams. The tablets are 25 milligrams. Okay, so how many tablets should the patient take? I realize you've probably already figured it out, but do the math anyway, because it's good to start off with problems that are super simple, because then that helps you to work through the ones that might not be. So we have 50 of Demerol that is needed for our patient. The tablets are 25 milligrams each. So what we can say for our proportions, because remember, proportions are 2 ratios, right? One is we have 1 tablet, and that tablet is 25 milligrams. Okay. Then we have our X. We don't know. We don't know how many tablets that we're going to need, right? Over the fact that we know we need 50 of Demerol. Then we are going to cross multiply, right? And what that's going to give us is 50 milligrams equals 25x. Break it down farther. X will equal 25 divided by 50 equals 2 tablets. Hopefully everybody's got that. Let's do another one. Let's do the second one, because I know these really proportions are, you get 2 ratios. There's one piece that you don't have, so you're always solving for X, but what that X is that you're looking for does move around. So let's do number 2. 1 millivolt of electricity causes the stylus of an electrocardiograph or an ECG machine to move 10 millimeters vertically. Okay, so not exciting stuff, right? But here's what we know. We have 1 millivolt equals 10 millimeters. How many millimeters would the stylus have to move with 3.5 millivolts of electricity. So here's what we don't know. So we know the whole first ratio. We know half of the second one. So again, we're going to be solving for x. So we take this one, 1 millivolt equals 10 mils, right? Then, because we keep our millivolts on the same side, remember I said before your x moves around. We don't know how many millimeters. We know that we have 3.5 millivolts. So that's going to go on top. And then you're going to do your magic crossing, right? So x is going to equal 3 millivolts times 10 millimeters. So the final answer is that x equals 35 millimeters. Now what you can do too is you can plug this into the ratio. You can go back and turn these into two separate ratios and see if they equal. Hey everybody, I lost my connection on my computer for a little bit. Hopefully we're still good and you understand what I was saying about plugging your answer back in to see if both ratios match each other like they're supposed to. Okay, let's do another one because I think ratios are a little more challenging. Let's do one that's actually related to the lab. So the third one is a lab technician can clean 45 pipettes every hour with a washer, right? So 45 pipettes can be cleaned in 1 hour. That is our first ratio, right? Even though, you know, one is talking about pipettes and one is talking about hours. Now, how many can he clean in 15 minutes? Both time periods must be in the same format. So this is what we're missing from this ratio. So since this is minutes and this is an hour, they need to always be in the same formatting. So we need to convert this one to minutes. So we're going to make that 60 minutes, okay? So we can do 45 pipettes in 60 minutes. And over here, we have our x because we don't know, in 15 minutes. Okay. So now we need to convert it. We're going to do all of our magic. So 60 and x, right, because we cross multiply, equals 45 pipettes times 15, right? Okay, so then we're going to bring our 60 over. So x, here, let's carry this over, just so that all the work is on the same page. So we had 60x equals 45 times 15. So now we want to solve for x, okay? So we know 45 times 15, you know, you can get your calculator out and determine that that's 675, right? So we're going to do 675 divided by 60. So x equals 11.25. Now in this instance, you can't have 1/4 of a pipette, right? So you need to think about what you're solving for, right? You know, if this was a solution and you needed to add 11.25 milligrams of something, that's doable. So make sure that you're looking at what the problem is asking. It's asking you how many pipettes can be washed. You can't wash 11 1/4 because you're not going to break a pipette up into fourths. So the answer will be 11 pipettes. because remember, you're going to round. So if we would do 11.75 pipettes, for example, then you would round it up to 12. So you can do 11 pipettes in 15 minutes. And again, you can go back in and check your work. Now in this situation, because we had to round, it might not come up totally exactly perfect, but you will know that that is because of that. Okay? So I hope that this helped you to understand ratios and proportions a little bit. So ratios, you have two values, and it's all about their relation to each other. Right? You know, 1 to 20, things like that. And you're always going to be given those two values. Proportions are really two ratios and their relationship to one another. And usually you're going to be missing one number that you have to solve for. So you're solving for x a lot and you're doing your cross multiplying. All right, so that's pretty much it. Just remember to make sure that you convert your ratios and proportions down to the lowest denominator that they can be. And if you have any questions about this content, definitely reach out. I'm going to also do a short one on temperature soon, and then I will cross over to the exciting world of molarity and normality. So have a good day.